Ports are available for S-parameter extraction, and although they are not strictly monitors, we will discuss them here. Ports act as a combination of a frequency domain power monitor, mode expansion monitor, and mode source, and they're primarily used for extracting S-parameters of a device. S-parameters are scattering parameters used to characterize the transmission and reflection of devices, and are often useful for performing circuit-level simulations where each element of the circuit is represented by its S-parameters. The image on the left shows a port in the CAD view, and the image on the right shows the equivalent combination of source and monitors. Since the port object has all of the functionality in a single object, it's simpler than setting up a combination of monitors and source and having to set up the properties for all of them. Port objects can be added from the port button in the top toolbar. And once you add a port, the ports group will automatically be generated as a child of the simulation region. The port group is a container which holds all of the port objects, and it's where you can specify which port will act as the source and what mode will be injected by the port when the simulation is run. Since ports are a child of the FDTD simulation region, this means that the simulation region must be added before a port can be added, which isn't the case for other monitors or sources. The arrows in the CAD view show the input and output directions of the port. The active port where the mode will be injected has a pink arrow in the source injection direction. Other ports have a green arrow in the input direction, and red arrows indicate the output directions of each port. In the port object, you can select the modes of interest the same way as mode expansion monitors from the Modal Properties tab. You can also choose to calculate the characteristic impedance of the selected modes in the Impedance tab. The characteristic impedance is calculated by the power over current squared, where power is calculated by integrating the pointing vector over the cross-section area of the mode, and the current is calculated by integrating the magnetic fields around a loop enclosing the mode. Once the characteristic impedance calculation is enabled, you can specify the integration region over which to calculate the P and I values. The results and effective, the effective index of the modes, mode profiles, and Z0, the characteristic impedance, are available before running the simulation. Once the simulation has been run, you can also obtain the S result, as well as all of the results that would be available from the mode expansion monitor, field power monitor, and mode source under the port modal expansions, port monitor results, and port source results sections of the result view window. To get the S parameters of a device, you will typically need to run multiple simulations. If a device has no symmetry, then one simulation is needed to obtain each column of the S matrix, where in each simulation one port mode is excited, and the reflection and transmission through the remaining ports is measured. The running and collecting of the S results for the full S parameters can be automated using the S parameter sweep tool. After running the sweep, you can choose to export the S parameter data from the sweep to a .dat file, which can be loaded in Interconnect, Lumerical's circuit simulation tool. For a detailed tutorial on using the S parameter sweep tool, see the related links below.